Hey there, builders and breakers. Today, we're diving into the world of industrial control systems. These systems are the backbone of critical infrastructure. Think power grids, water treatment plants, and manufacturing facilities. They're essential for keeping our world running smoothly. Now, imagine if someone messed with these systems. Chaos, right? That's where the Purdue model comes in. It's like a blueprint for securing these vital systems. Think of it as a layered approach to defense, making it much harder for the bad guys to wreak havoc. The Purdue model divides an industrial control system into 6 distinct levels. Each level represents a different aspect of the system. This layered approach helps us understand the flow of information and control within the system. More importantly, it allows us to implement security measures at each level, making the entire system more robust and resilient. Just like a good myth needs busting, a good security system needs layers. The Purdue model gives us the framework to do just that, ensuring our critical infrastructure stays safe and sound. At the very bottom, we have level 0. This is where the action happens, the physical processes themselves. Think giant turbines spinning, robotic arms welding, and chemical reactions bubbling away. Level 0 is all about sensors and actuators. Sensors collect data about the physical processes. They measure things like temperature, pressure, and flow rate. Actuators, on the other hand, receive commands from the upper levels. They control valves, motors, and other physical devices to keep things running smoothly. Security at this level is crucial. Imagine a malicious actor tampering with a sensor. They could feed false information to the control system, potentially leading to disastrous consequences. That's why physical security measures are paramount at level 0. We're talking fences, cameras, and access control systems to keep unauthorized personnel away from these critical components. Because when it comes to industrial control systems, a secure foundation is everything. Moving up the ladder, we reach level 1, basic control. Here, we find the workhorses of the ICS world, programmable logic controllers and remote terminal units. These devices act as the brains of level 0. They receive data from sensors, process it according to pre-programmed instructions, and then send commands to actuators. It's all about real-time control, making sure those physical processes are running within safe and efficient parameters. Security at this level focuses on protecting PLCs and RTUs from unauthorized access and tampering. Strong passwords, firewalls, and intrusion detection systems are essential. Remember, if someone gains control of these devices, they can manipulate the physical processes, with potentially catastrophic results. We want to keep the brains of our ICS safe from any unwanted tampering. By implementing robust security measures at level 1, we ensure these critical devices operate as intended, keeping our industrial processes running smoothly. Up another rung, we arrive at level 2. Supervisory control. This is where things start to get interesting. Here, we find human-machine interfaces, those fancy screens with buttons, graphs, and alarms that operators use to monitor and control the entire process. Level 2 is all about supervision and optimization. It's where operators can get a bird's-eye view of the entire operation, adjust set points, and respond to alarms. Think of it as the control room, where decisions are made that impact the entire process. Security at this level is paramount, because compromising level 2 gives attackers significant control over the entire system. We're talking about strong authentication mechanisms, access control lists, and intrusion detection systems to prevent unauthorized access and malicious activities. We wouldn't want just anyone walking into the control room and flipping switches, would we? That's why securing level 2 is crucial for maintaining the integrity and stability of our industrial control systems. Section 5. Levels 3 and 4. Operations management and business planning. As we ascend further, we reach levels 3 and 4. These levels are less about the nitty-gritty of controlling physical processes. and more about the bigger picture operations management, data analysis, and business planning. Level 3, the operations management level, is where production schedules are set, performance is analyzed, and adjustments are made to optimize efficiency. Think of it as the strategic decision-making layer, where data from the lower levels is used to improve overall operations. Level 4, the business planning level, is where the bigwigs hang out. This is where long-term strategies are developed, budgets are allocated, and decisions are made that impact the entire organization. Security at these levels is still important, but it takes on a different flavor. We're less concerned with someone hacking into a PLC and more concerned with protecting sensitive data from theft or manipulation. Think firewalls, intrusion detection systems, and strong encryption to safeguard valuable information. While not directly controlling the physical processes, these levels hold the keys to the kingdom. Protecting them from cyber threats is essential for maintaining the integrity and confidentiality of our industrial operations. Section 6. Security Implications of the Purdue Model. Now that we've climbed the Purdue Model ladder, let's talk about why it matters for security. The model's layered approach provides a framework for implementing security measures at each level, creating a defense-in-depth strategy. One key concept is network segmentation. By dividing the network into smaller, isolated segments, we limit the impact of a security breach. If one segment is compromised, the attacker can't easily move laterally to other parts of the network. Another important aspect is access control. The Purdue model emphasizes the principle of least privilege, meaning users should only have access to the information and systems they need to do their jobs. This helps prevent unauthorized access and limits the potential damage an attacker can inflict. Data flow is also crucial. The Purdue model helps us understand how information moves between different levels and implement security measures to protect that data in transit and at rest. This includes encryption, firewalls, and intrusion detection systems to safeguard sensitive information from prying eyes. By following the principles of the Purdue model, we create a more secure and resilient industrial control system. It's like building a fortress around our critical infrastructure, making it much harder for the bad guys to breach our defenses. Section 7. Modern Challenges in Industrial Control Systems. But hold on, our work isn't done yet. The world of industrial control systems is constantly evolving, and so are the challenges we face in securing them. One major trend is the convergence of information technology, IT, and operational technology, OT. In the past, these systems were separate, but now they're becoming increasingly interconnected, which introduces new security risks. Another challenge is the rise of cloud computing. While the cloud offers many benefits, it also creates new attack vectors that we need to address. And let's not forget about the ever-evolving threat landscape. Cybercriminals are becoming more sophisticated, developing new and innovative ways to exploit vulnerabilities in industrial control systems. To stay ahead of the game, we need to adapt our security practices. This includes implementing strong authentication mechanisms, embracing multi-factor authentication, and staying up to date on the latest security patches and updates. The world of cybersecurity is a game of cat and mouse, but by understanding the Purdue model and adapting to new challenges, we can keep our industrial control systems safe and secure. Section 8. Conclusion. The enduring relevance of the Purdue model. So, there you have it, folks. The Purdue model may not be as flashy as a Hollywood explosion, but it's just as important for keeping our world running smoothly. It's a blueprint for securing our critical infrastructure, a layered approach to defense that helps us stay one step ahead of the bad guys. And while the world of industrial control systems is constantly evolving, the principles of the Purdue model remain as relevant as ever. By understanding the model's layers, implementing robust security measures, and adapting to new challenges, we can ensure that our power grids stay lit, our water remains clean, and our factories keep humming along. Just like a well-designed experiment, a well-secured industrial control system requires careful planning, meticulous execution, and a healthy dose of paranoia. The Purdue model gives us the tools we need to do just that, ensuring a safer and more resilient future for us all. And that's a myth worth busting.